Introducing Grade 11 Physics, SPH3U. Students in Grade 11 Physics, SPH3U, will delve into the fundamental principles governing motion and forces, equipping them with a strong foundation in kinematics, such as understanding linear motion, acceleration, velocity, and displacement. The course will cover different types of forces, including gravitational, frictional, and tensional forces, providing students with a comprehensive understanding of how forces impact objects in motion and at rest. Energy transformations will be a key focus, with students learning about the various forms of energy, including kinetic, potential, and thermal energy, and how energy changes from one form to another in different systems. Exploring the properties of mechanical waves and sound, students will investigate wave characteristics, wave behavior, and the nature of sound waves, enhancing their comprehension of wave phenomena and the principles of sound propagation. The study of electricity and magnetism will deepen students' understanding of electric circuits, electromagnetic principles, and the relationship between electricity and magnetism, enabling them to analyze and explain various electrical and magnetic phenomena. Through hands-on experiments and scientific investigations, students will develop critical thinking and problem-solving skills as they apply the laws of physics to real-world scenarios, fostering a deeper appreciation for the scientific method and empirical inquiry. Examining the interconnections between physics and technology, students will explore how advancements in physics have shaped technological innovation and influenced societal development, prompting them to consider the ethical and environmental implications of technological applications in physics. Aligned with the Ontario curriculum, Grades 11 and 12, Science, 2008, revised, this university-level course carries a credit value of 1. And requires the successful completion of the Grade 10 Academic Science course, SNC2D, as a prerequisite. This course is comprised of 5 units and a final assessment as follows. Unit 1. Kinematics, 22 hours. Students will begin by exploring the fundamental principles of kinematics, focusing on the concepts of uniform and non-uniform linear motion in both 1 and 2 dimensions. Through theoretical discussions and practical examples, students will grasp the essence of motion and its mathematical representation. This unit will provide students with opportunities to investigate and differentiate between uniform and non-uniform motion, enabling them to apply their knowledge to solve various problems related to velocity, acceleration, and displacement. They will learn to interpret graphs and equations that depict motion in different scenarios. Through qualitative and quantitative analysis of motion, students will develop critical thinking skills and the ability to identify patterns and relationships in kinematic data. They will engage in hands-on activities and experiments to enhance their understanding of motion concepts and their real-world applications. Students will explore how technologies such as GPS systems, motion sensors, and transportation systems rely on kinematics principles to function effectively. They will analyze the design and operation of these technologies, considering how kinematics is utilized to optimize performance and efficiency in various applications. As part of their learning experience, students will critically evaluate the social and environmental implications of technologies that employ kinematics concepts. They will consider how these technologies contribute to society's advancement and the potential effects on the environment, sparking discussions on sustainability and ethical considerations. By the end of this unit, students will have honed their problem-solving skills and analytical thinking, gaining a deeper understanding of how kinematics governs motion in the physical world. They will be able to apply their knowledge to make informed decisions about the use of technology and its impact on society and the environment. The 22-hour duration of this unit allows for comprehensive coverage of kinematics concepts, providing students with ample time to engage with the material, participate in hands-on activities, and work through problem-solving exercises to deepen their understanding of linear motion. Unit 1. Kinematics sets the foundation for students' exploration of physics, laying the groundwork for further study in forces, energy transformations, waves, and electricity. Unit 2. Forces, 20 hours. Students will focus on understanding the key concepts of forces, particularly the relationship between changes in velocity and unbalanced forces in one dimension. They will investigate how forces influence motion and explore the effects of different forces on objects. Qualitatively and quantitatively analyzing net force, acceleration, and mass, students will develop a deeper understanding of the fundamental principles of dynamics. They will engage in problem-solving activities that require them to apply Newton's laws of motion to explain the motion of objects under the influence of various forces. Through hands-on experiments and simulations, students will explore the practical applications of forces in real-world scenarios. They will have the opportunity to collect and analyze data related to forces, acceleration, and mass, using techniques such as force diagrams and free body diagrams to represent the interactions between objects and forces. Students will critically assess existing technologies that incorporate concepts related to dynamics and Newton's laws, identifying potential areas for improvement or innovation. They will propose enhancements to these technologies based on their understanding of how forces impact the design, operation, and efficiency of technological systems. An emphasis will be placed on evaluating the social and environmental impact of technologies that utilize forces and dynamics principles. Students will consider how these technologies contribute to societal progress and economic development, as well as how they may affect the environment and natural resources. Through discussions and research projects, students will explore the ethical implications of using force-based technologies, considering issues such as safety, sustainability, and equity. They will analyze case studies and real-life examples to understand the broader implications of technological advancements in the context of forces and dynamics. The 20-hour duration of this unit provides students with ample time to delve into the intricacies of forces and dynamics, allowing for in-depth exploration of key concepts and principles. Students will have the opportunity to engage in hands-on activities, group discussions, and problem-solving tasks to reinforce their understanding of forces and their application in physics. Unit 2. Forces serves as a critical component of the Grade 11 Physics curriculum, building on students' foundational knowledge of kinematics and laying the groundwork for deeper exploration of energy transformations, waves, and electricity. Unit 3. Energy and Society, 19 hours. Students will engage in a comprehensive exploration of various forms of energy, including work, efficiency, power, gravitational potential energy, kinetic energy, nuclear energy, and thermal energy. They will develop a deep understanding of these concepts and how they relate to energy transformation processes. The unit will focus on energy transformations and the law of conservation of energy, allowing students to analyze how energy is converted from one form to another in different systems while respecting the principle of energy conservation. Students will apply these concepts to solve problems related to energy transformations. Students will critically analyze technologies that incorporate principles and concepts related to energy transformations, such as renewable energy systems, electrical power generation, and energy-efficient technologies. They will assess how these technologies impact society and the environment, considering factors such as energy sustainability and resource conservation. The unit will delve into the social and environmental implications of technologies that utilize energy transformations, prompting students to evaluate the benefits and challenges associated with these technologies. Students will explore how energy technologies can contribute to economic growth, environmental stewardship, and energy security. Students will engage in discussions and research projects that address ethical considerations related to energy technologies, including issues of energy equity, access to clean energy sources, and environmental justice. They will explore case studies and examples to understand the broader societal impacts of energy-related technologies. The 19-hour duration of this unit provides students with ample time to delve into the complex concepts of energy and its societal implications, allowing for in-depth exploration and analysis of key principles. Unit 3. Energy and Society serves as a crucial component of the Grade 11 Physics curriculum, building on students' foundational knowledge of kinematics and forces, and laying the groundwork for further exploration of waves, electricity, and magnetism. Unit 4. Waves and Sounds, 20 hours. Throughout Unit 4, students will delve into the properties of mechanical waves and sound, developing a comprehensive understanding of the fundamental principles governing wave behavior, wave propagation, and sound production. They will explore concepts related to wave motion, frequency, wavelength, amplitude, and speed. By solving problems related to wave properties and sound phenomena, students will enhance their analytical and problem-solving skills, applying mathematical principles to interpret wave data, calculate wave characteristics, and predict wave behavior in different contexts. They will develop a deeper understanding of wave mechanics and sound waves through practical applications. Students will analyze the impact of mechanical waves and sound on technology, structures, society, and the environment, examining how these phenomena influence the design and operation of communication systems, building structures, and environmental monitoring devices. They will assess the positive and negative effects of waves and sound on various aspects of human life and ecosystems. Through discussions and research projects, students will explore methods to mitigate the negative side effects of mechanical waves and sound, considering strategies to reduce noise pollution, control vibration levels, and improve sound quality in different settings. They will examine technological solutions and engineering interventions aimed at reducing the impact of wave disturbances. The unit's 20-hour duration allows for in-depth exploration of wave and sound principles, providing students with ample time to engage with the material, conduct experiments, and participate in problem-solving activities. Students will have the opportunity to apply their knowledge to real-world scenarios and explore the practical implications of wave behavior and sound phenomena. Unit 4. Waves and Sounds serves as a crucial component of the Grade 11 Physics curriculum, building on students' foundational knowledge of kinematics, forces, and energy transformations. It lays the groundwork for further study in electricity, magnetism, and modern physics, providing students with a solid understanding of wave mechanics and sound waves as they relate to technological advancements and societal impacts. Students will develop a deeper appreciation for the role of mechanical waves and sound in shaping our understanding of the physical world, as well as their importance in driving innovation, communication, and environmental sustainability. Unit 5. Electromagnetism, 20 hours. Students will delve into the properties of magnetic fields and the principles governing current and electron flow in Unit 5. Electromagnetism. They will explore the fundamental concepts of electromagnetism, including magnetic fields, magnetic induction, electromagnetic waves, and the interactions between electricity and magnetism. By solving problems related to magnetic fields and electric circuits, students will enhance their problem-solving abilities and analytical skills. They will apply mathematical principles to analyze circuit diagrams, calculate electrical properties, and predict the behavior of electrical systems under different conditions. Students will analyze the social, economic, and environmental impact of electrical energy production and technologies related to electromagnetism. They will examine how advancements in electromagnetism have transformed energy generation, distribution, and consumption, shaping modern societies and economies. In addition to evaluating the impact of electromagnetism on society and the environment, students will propose methods to enhance the sustainability of electrical energy production. They will explore strategies to increase energy efficiency, reduce environmental pollution, and promote the adoption of renewable energy sources in the context of electromagnetism. The 20-hour duration of this unit allows students to engage in a comprehensive exploration of electromagnetism, providing ample time to explore the intricacies of magnetic fields, electric circuits, and electromagnetic technologies. Students will have the opportunity to deepen their understanding of these concepts through practical applications and problem-solving tasks. Unit 5. Electromagnetism serves as a critical component of the Grade 11 Physics curriculum, building on students' foundational knowledge of kinematics, forces, energy transformations, and waves. It lays the groundwork for further study in modern physics and quantum mechanics, providing students with a solid understanding of the principles of electromagnetism and its applications in technology and society. By studying electromagnetism, students will gain valuable insights into the role of electricity and magnetism in shaping technological advancements, economic development, and environmental sustainability. RST and final exam 30%. The final exam, lasting for 3 hours, serves as a critical component of the evaluation process, comprising 30% of the student's final grade in the Grade 11 Physics course. This proctored exam will assess students' comprehensive understanding of the course material, including concepts related to kinematics, forces, energy, waves, and electromagnetism. Students will be required to demonstrate their knowledge and skills across various topics covered throughout the course, applying critical thinking, problem-solving techniques, and analytical reasoning to solve physics-related problems and questions within a time setting during the final exam. The RST, rich summative task, spanning 6 hours, is another significant assessment that contributes 30% towards the student's final grade. This proctored task will assess students' ability to apply their understanding of physics concepts to real-world scenarios and practical applications, fostering the integration of theoretical knowledge with hands-on experimentation and analysis. During the RST, students will be tasked with completing a series of challenging and comprehensive tasks that require them to demonstrate their proficiency in concepts related to kinematics, forces, energy transformations, waves, and electromagnetism. They will utilize scientific inquiry skills, data analysis techniques, and problem-solving strategies to address complex physics scenarios. The RST provides students with the opportunity to showcase their holistic understanding of physics principles, problem-solving abilities, and practical application of scientific concepts in a structured and time-constrained assessment format. This task aims to evaluate students' mastery of the course content and their ability to integrate and synthesize knowledge across various physics topics. Both the final exam and the RST are designed to assess students' proficiency in Grade 11 Physics, offering a comprehensive evaluation of their knowledge, skills, and competencies in physics concepts and applications. These assessments aim to provide students with a platform to demonstrate their academic achievements and readiness to progress to higher levels of physics education. By the end of the course, you will have achieved the following overall expectations: A. Scientific investigation skills and career exploration. Throughout the Grade 11 Physics course, students will develop and showcase their scientific investigation skills by engaging in hands-on experiments, data collection, and analysis. They will demonstrate proficiency in initiating and planning investigations, performing and recording data accurately, analyzing and interpreting results, and effectively communicating their findings using scientific language and formats. Students will apply the scientific method to design and conduct experiments, form hypotheses, collect data, and draw valid conclusions based on evidence. They will learn how to use appropriate tools and technologies to collect and analyze data, ensuring accuracy and precision in their scientific investigations. By the end of the course, students will have honed their ability to critically analyze and interpret scientific data, identifying patterns, trends, and relationships within experimental results. They will use mathematical and analytical skills to draw conclusions and make inferences based on their findings, developing a robust understanding of scientific inquiry. Through various laboratory activities and projects, students will enhance their communication skills by effectively conveying their scientific ideas, methodologies, and results in written reports, oral presentations, and visual representations. They will learn to communicate scientific concepts clearly and concisely, addressing both technical and lay audiences. Additionally, students will have the opportunity to explore and identify careers related to the fields of science studied in the course, such as physics, engineering, technology, and research. They will research and describe various career paths, job roles, and opportunities available to individuals with a background in physics and related disciplines. Students will learn about the contributions of scientists to the fields of physics and other sciences, recognizing the significant achievements and discoveries that have shaped our understanding of the natural world. They will specifically explore the contributions of Canadian scientists to scientific advancements, highlighting the impact of Canadian researchers on global science and innovation. Through career exploration activities, guest speakers, and research assignments, students will gain insights into the diverse range of professions available to individuals with a background in science. They will be encouraged to consider their interests, skills, and values about potential career paths in the fields of science and technology. By integrating scientific investigation skills with career exploration, students will develop a deeper appreciation for the relevance of physics in everyday life and the broader impact of scientific research on society. They will be equipped with the knowledge and skills needed to pursue further studies or careers in science-related fields, fostering a lifelong passion for scientific inquiry and discovery. B. Kinematics students will critically analyze various technologies that utilize concepts related to kinematics, such as GPS systems, motion sensors, and transportation systems. They will assess the social and environmental impact of these technologies, considering factors such as energy efficiency, sustainability, and resource conservation. Through qualitative and quantitative investigations, students will explore the principles of uniform and non-uniform linear motion, analyzing velocity, acceleration, displacement, and other key parameters. They will develop problem-solving skills by applying kinematics formulas to solve related problems and scenarios. By the end of the course, students will demonstrate a thorough understanding of uniform and non-uniform linear motion in both 1 and 2 dimensions. They will be able to differentiate between these types of motion, interpret motion graphs, and make calculations related to speed, velocity, and acceleration in various contexts. Throughout their study of kinematics, students will develop critical thinking skills by evaluating the relationships between motion parameters, forces, and energy transformations. They will learn to make connections between theoretical concepts in kinematics and practical applications in technological systems and everyday phenomena. In addition to mastering the basic concepts of kinematics, students will explore advanced topics such as projectile motion, circular motion, and relative motion. They will investigate how these complex motion phenomena are influenced by factors such as gravity, friction, and external forces, expanding their knowledge of kinematics principles. Students will apply their understanding of kinematics to analyze and interpret motion patterns in various contexts, such as sports, transportation, and mechanical systems. They will develop the ability to predict and explain the motion of objects based on given parameters, fostering a deeper appreciation for the predictability and reliability of kinematic principles. By integrating theoretical knowledge with practical skills, students will be able to effectively communicate their findings and explain kinematics concepts to others. They will develop scientific literacy by articulating the principles of kinematics and their applications in technology, society, and the natural environment. Forces. Students will conduct thorough analyses of technologies that incorporate concepts related to dynamics and Newton's laws, proposing enhancements to optimize their performance and efficiency. They will assess the social and environmental impacts of these technologies, considering factors such as energy consumption, resource utilization, and sustainability. Through qualitative and quantitative investigations, students will explore the concepts of net force, acceleration, and mass, gaining a deep understanding of how these parameters interact in physical systems. They will apply mathematical formulas and principles to solve problems related to forces, acceleration, and mass, enhancing their problem-solving skills. By the end of the course, students will demonstrate a strong understanding of the relationship between changes in velocity and unbalanced forces in one dimension. They will be able to analyze how forces impact velocity changes and motion characteristics, drawing connections between force interactions and resulting accelerations in linear motion scenarios. Throughout their study of forces, students will develop critical thinking skills by evaluating the effects of forces on motion, energy transformations, and mechanical interactions. They will learn to analyze and predict the outcomes of force applications in various contexts, fostering a deeper understanding of Newton's laws of motion. In addition to mastering the fundamental concepts of forces and dynamics, students will delve into advanced topics such as friction, tension, and centripetal force. They will investigate how these forces affect motion patterns, equilibrium conditions, and circular motion scenarios, broadening their understanding of force interactions in diverse situations. Students will apply their knowledge of forces to assess the design and operation of technological systems, machinery, and structures. They will analyze how forces are utilized in engineering applications, transportation systems, and mechanical devices, identifying opportunities for improvement and innovation based on their understanding of force dynamics. By integrating theoretical concepts with practical applications, students will develop the ability to communicate their findings and insights related to forces effectively. They will collaborate with peers, present their analyses, and explain force principles clearly and concisely, enhancing their scientific communication skills and overall understanding of physics concepts. Energy and society. Students will critically analyze various technologies that utilize principles of energy transformations, such as renewable energy systems, energy-efficient devices, and power generation technologies. They will assess the social and environmental impact of these technologies, evaluating their contributions to sustainability and resource conservation. Through theoretical analyses and practical applications, students will investigate energy transformations and the law of conservation of energy. They will explore how energy is conserved and transferred between different forms, such as potential energy, kinetic energy, nuclear energy, and thermal energy, in various systems. By the end of the course, students will demonstrate a deep understanding of concepts such as work, efficiency, power, and different forms of energy, including gravitational potential energy, kinetic energy, nuclear energy, and thermal energy. They will be able to describe how energy is converted from one form to another and transferred as heat in different contexts. Throughout their study of energy, students will develop critical thinking skills by evaluating the efficiency, sustainability, and environmental impact of energy technologies. They will consider how energy production, distribution, and consumption practices influence society, economies, and the natural environment, leading to discussions on energy policies and resource management. In addition to mastering the fundamental concepts of energy and energy transformations, students will explore advanced topics such as energy efficiency, heat transfer mechanisms, and renewable energy solutions. Students will apply their knowledge of energy principles to assess the performance and design of energy-related technologies, infrastructure, and energy conservation measures. They will analyze energy consumption patterns, identify opportunities for energy reduction, and propose strategies to enhance energy sustainability and environmental stewardship. By integrating theoretical knowledge with practical applications, students will develop the ability to communicate their findings and insights related to energy concepts effectively. Waves and sound. Students will conduct an in-depth analysis of how mechanical waves and sound impact various aspects of society, technology, structures, and the environment. They will evaluate the positive and negative effects of waves and sound, and explore strategies to mitigate any negative impacts, such as noise pollution and structural vibrations. Through qualitative and quantitative investigations, students will explore the properties of mechanical waves and sound, including wave characteristics such as frequency, wavelength, amplitude, and speed. They will apply mathematical formulas and analytical skills to solve problems related to wave behavior, sound propagation, and wave interactions. By the end of the course, students will demonstrate a comprehensive understanding of the properties of mechanical waves and sound, as well as the principles underlying their production, transmission, interaction, and reception. They will be able to describe how waves and sound are generated, propagated, and detected in various mediums. Throughout their study of waves and sound, students will develop critical thinking skills by evaluating the impact of wave phenomena on technology, sound engineering, music production, and environmental monitoring. They will consider how waves and sound influence human perception, communication, and the design of acoustic spaces. In addition to mastering the fundamental concepts of waves and sound, students will explore advanced topics such as wave interference, resonance, and sound quality. They will analyze how these phenomena influence wave patterns, sound propagation, and the perception of acoustic signals, broadening their knowledge of wave mechanics and acoustics. Students will apply their understanding of waves and sound principles to assess the design and operation of technologies, systems, and structures that utilize wave phenomena. They will analyze how waves are utilized in communication devices, medical imaging technologies, and environmental monitoring systems, identifying opportunities for improvement and innovation. By integrating theoretical knowledge with practical applications, students will develop the ability to communicate their findings and insights related to waves and sound effectively. They will articulate the principles of wave behavior, sound propagation, and wave interactions in written reports, presentations, and discussions, fostering a deeper understanding of the role of waves and sound in technology, society, and the natural environment. Electricity and magnetism. Students will conduct a comprehensive analysis of the social, economic, and environmental impact of electrical energy production and technologies related to electromagnetism. They will propose strategies to enhance the sustainability of electrical energy production, considering factors such as energy efficiency, renewable energy sources, and environmental stewardship. Through qualitative and quantitative investigations, students will explore the properties of magnetic fields and electric circuits. They will analyze the behavior of magnetic fields, electric currents, and electron flow, applying mathematical formulas and principles to solve problems related to magnetic interactions, circuit properties, and power transmission. By the end of the course, students will demonstrate a solid understanding of the principles of magnetic fields, electric currents, and electron flow. They will be able to describe how magnetic fields are generated, how electric circuits operate, and how these principles are utilized in technologies that produce and transmit electrical energy. Throughout their study of electricity and magnetism, students will develop critical thinking skills by evaluating the impact of electromagnetic technologies on society, economies, and the environment. They will explore how advances in electromagnetism have transformed energy production, transmission, and consumption practices, shaping modern infrastructure and technology. In addition to mastering the fundamental concepts of electricity and magnetism, students will explore advanced topics such as electromagnetic waves, electrical power generation, and energy conversion devices. They will analyze how these concepts are applied in power systems, communication networks, and renewable energy technologies, expanding their knowledge of electromagnetism applications. Students will apply their understanding of electricity and magnetism principles to assess the performance and efficiency of electrical technologies, machines, and power systems. They will analyze energy consumption patterns, identify opportunities for energy conservation, and propose strategies to enhance the sustainability and reliability of electrical energy production. By integrating theoretical knowledge with practical applications, students will develop the ability to communicate their findings and insights related to electricity and magnetism effectively. They will articulate the principles of electromagnetism, electrical circuits, and energy production in written reports, presentations, and discussions, fostering a deeper understanding of the role of electromagnetism in technology, society, and environmental sustainability.